Hi, talk about forward and future contracts. These are two financial instruments that allow to lock in a purchase of an asset in the future. Okay, so we're going to begin the lecture by forward contracts. So consider a financial asset S that pays no dividends, and consider a non-random delivery price K. A forward contract is a contract that allows us to lock in a future purchase of the asset S. So the forward contract has some starting date, which is T0. So at this date, this is when we purchase, this is when we settle the contract. And at this point in time, we're going to establish the delivery price K, at which we will buy the asset at a future time, capital T contract. Okay? So the value of this contract at any intermediate time between the start of the contract and the maturity of the contract is given by this expression over here, okay? Where this BT denotes the value of the bank account at time T, okay? And where this guy over here is the usual risk neutral expectation, okay? So we can see that this formula is nothing but the usual risk-neutral pricing, where we have that the value is given by the risk-neutral expectation of the discounted payoff. At maturity, the payoff of the contract is given by the difference between the current price of the asset and the price at which we are forced to buy the asset. In this way, if the asset has a value greater than the price at which we can buy it, then our contract will have a positive value which is equal to the difference between the price at the market and the price at which we are able to buy the contract. And if the asset has lower value than the price at which we are forced to buy the asset, then obviously the contract will have negative value, and the value will be again the difference between the two prices. Remember that value of the financial assets discounted by the bank account are martingales under the risk neutral measure, and thus for any asset we have that the value at little t satisfies this equation over here. And similarly, for the zero coupon bond with maturity at capital T, we also have this equation which comes from the same reasoning. Okay, so using these two equations, using these two facts, we can decompose the value of the forward into two separate terms. Okay, so this term, which depends on the financial stat, okay, is going to give us this current price of the asset over here, and then this fixed amount K, which is fixed at the inception of the contract, okay, once we take it out of the risk neutral expectation, is going to be multiplied by the zero coupon bond. Okay, so this formula not only is giving us a nice and simple pricing formula for the value of the forward contract, but it is also suggesting, well, it's not suggesting, it's giving us some strategy for replicating the contract just by taking a long position on the financial asset that is underlying in the forward contract and a short position and a short position in zero coupon bonds. Okay, we will just take as many zero coupon bonds as the delivery price of the forward contract. Now, the forward price is defined as the delivery price such that the value of the forward contract has zero value. Okay, so if we take the equation that we previously saw that gave us the value of the contract and we make the value of the contract equal to zero, we will see that the delivery price that is making the value of the contract equal to 0 is going to be given by this expression. Okay, so if we take this delivery price for our forward contract, the value of the contract is going to be 0 at time little t. Okay, and recall also that the t forward measure satisfies this equation over here in such a way that the price of a financial asset is the expected value under the T forward measure of the future price times the zero coupon bond. Okay, so if we use this equation to rewrite the forward price, what we get is that the forward price is nothing but the expected value of the asset at the maturity of the contract under the T forward measure. Okay, this is the forward price. Okay, this is the price that is going to make the forward contract have 0 value at time little t. So see that the forward price is that we saw in the previous slide is depending on time little t. Okay, so it depends on obviously the asset, which is the underlying of the forward contract. It depends on the maturity of the forward contract, okay, where the purchase of the asset will take place, and it also depends on the point in time in which we are. Okay, so in other words, the forward price for some given maturity on a financial asset S is a stochastic process that is evolving in time. Okay, so we have different forward prices as we move through time. So given two dates T1 and T2, if we buy the contract at T1 at the forward price at that moment in time, okay, so if we buy the contract with this delivery price, the contract is going to have 0 value when we buy it. The value of the contract in some future time T2 is going to be given by this expression over here. Okay, so we see that if the forward price at some future date is not the same forward price as the forward price that we had when we purchased the contract, then the value of the forward contract is no longer going to be 0. Okay, so it may or it may not have 0 value in the future, but the value of the contract in general is not going to be 0 because the forward price is a stochastic process, it's moving in time, and so as the forward price is moving in time, then so is the value of the contract that we bought at time T1. Okay, so we have two stochastic processes now. One is the forward price and the other one is the value of the forward. Okay, note that these are two different concepts, okay, which obviously are interconnected, as the value of the forward that we bought in the past is depending on the conditions at which we bought the contract, and it's also depending on the current market conditions. It's depending on the current forward price. Okay, now a specific type of forward contracts are forward rate agreements. In this type of forward contracts, what we are buying is some interest rate for some future period. Okay, so we need three points in time in order to describe the contract. We are going to have some point in time t, that is when we enter into the contract, and then we are going to have two other points in time which are going to be denoted by capital T and capital S, which are going to denote the start and the end of the period for which we are buying this interest rate. Okay, so we are trying at some initial date little t we are locking up some interest rate for some future period which goes from capital T to capital S. And the interest rate that we are locking up, we are going to denote it by capital K. Okay, these contracts have two possible payment schemes. The first of the schemes is with two separate payments, with one initial payment at the beginning of the period equal to the nominal amount and one other payment at the end of the period equal to the nominal amount times 1 plus the interest rate times the length of the period. Notice that these two payments carry an opposite sign. So if the forward rate agreement these contracts have two possible payment schemes. The first scheme is with two separate payments. So we will make a payment at the beginning of the period equal to the nominal amount, and we will get a payment at the end of the period with an amount equal to the nominal amount times 1 plus the interest rate times the length of the period. This is equivalent to making an investment in this period at the interest rate specified under the forward rate agreement. The other possible payment scheme is that both payments are grouped together at the beginning of the period. In order to move the payment taking place at S in the other payment scheme and move it to T, this when we want to move the payment from the end of the period to the beginning of the period, we would have to multiply that payment by the zero coupon bond going from T to S. And that leads us to the expression that we can see over here. Okay, so this corresponds to the same payment that we already had at the beginning of the period, and this other payment is nothing but the payment that we had in the other scheme at the end of the period multiplied by the zero coupon bond, which is the way in which we can move this payment from the end of the period to the beginning of the period. Similarly to forward contracts with other assets as an underline, there is also the concept of the forward rate, which is the rate that makes the forward rate agreement have value equal to 0. No arbitrage arguments lead to the following expression for this forward rate agreement at time little t. Okay, so the interest rate that makes the forward rate agreement have value 0 at time little t is given by this expression, okay, where this guy over here is the spot rate available at little t for the period going from little t to S, and this guy over here is the spot rate available for the period going from little t to capital T. Notice that these spot rates are given in simple compounding as well as this forward rate, which is also given in simple compounding. Now we move to future contract. The value of the forward moves in time, and so does our exposure to a credit event. In case our counterparty would default at any time before maturity, we would lose the value of the forward at that point in time. Notice that the value of the forward tends to its payoff at maturity. That's the point in which our credit exposure is going to be the greatest. This raises the concern of possible losses due to the default of the counterparty whenever the contract has positive value for us. And as we were saying, this can be the greatest close to maturity. This has led to the creation of future contracts. These are similar contracts to forwards, but instead of having a unique payment at maturity, there exists a sequence of payments that take place every day, which reset the value of the future in such a way that it is always close to 0. These payments are managed by the exchange where the futures are traded, and they are automatically done into a margin account that we have to have, where positive payoffs are automatically paid in and where negative outflows are automatically extracted from. These future contracts also depend on the delivery price and are always traded at a delivery price such that the value of the contract is zero. This delivery price is called the future price, and obviously it depends on the asset and also on the maturity. The future price evolves in time due to effects of supply and demand of the future contracts, but it has to satisfy two conditions. The first one is that at maturity, the future price has to be equal to the spot price of the asset. And the other condition is that the changes in value determine the payoffs of the future contracts. So at a date Tj, we will see a payoff in our contract which will be equal to the increment of the future price between the day in which the payment takes place and the previous day. See that after each of these daily payments, the value of our contract will be once again zero, as it is equal to canceling the position after the payment and starting the new contract with the new future price. Also note that these contracts have a much more involved structure and therefore cannot be replicated in a straightforward manner as forward contracts can. We see that the future price of an asset S for a contract maturing at capital T is going to be equal to the risk neutral expectation of the future value of the asset at maturity of the future contract. In order to prove this, first we're going to assume that payments do not take place on a daily basis, but rather they are paid instantaneously, such that on any arbitrarily small interval of time we're going to have some payoff which is given by the difference in the future price in that time interval. We define the accumulated discounted payments at time t in this way. Okay, this is the integral in time of the changes in the forward times 1 over the bank account in order to discount the payments due to the change in the future price at every time u. Under this assumption of continuous payments in time, we see that the value of the future at time little t is the expectation under the risk neutral measure of all the future payments discounted by the bank account. And we can write the value of the future in terms of the process MT in this way. Given that the value of the future is always zero because the futures are always traded with the delivery price equal to the future price, then we can see that the process that we defined previously is a martingale under the risk neutral measure. Now, from the definition of the process MT, if we take derivatives, we see that the differential of MT is equal to the differential of the future price divided by the bank account. Thus, if our process MT is a martingale, then so is the future price. And therefore, just by the definition of martingale, we can see that the future price at time little t is the expectation under the risk neutral measure of the future price at maturity. Given that the future price at maturity is equal to the spot price at maturity, this leads to the desired result. As we had forwards on interest rates, we also have futures on interest rates. There are two widely categories of interest rate futures. On the one hand, we have short-term interest rates, and on the other hand, we have future markets on bonds. An example of the first of these categories are euro-dollar futures. These are futures which depend on the LIBOR, on the 3-month LIBOR, and we denote by LT the spot 3-month LIBOR at time t. And the quote market for the future is given by this expression over here, okay, where L sub f is the future on the LIBOR. A change in 1 basis point in the future is going to lead to a payoff of $25 according to this equation, where this 1 million over here represents the nominal of the contract. This 10 to the minus 4 represents a change in the forward LIBOR of the future LIBOR of 1 basis points, and the 1/4 over here is due to the fact that the underlying interest rate is a 3-month interest rate. We now make a brief comparison between forwards and futures. On the one hand, one of the most important differences is that forward contracts are over-the-counter derivatives. This means that they are traded bilaterally. We do not have an exchange where we can buy and sell forwards. Instead, what we do is contact some counterparty and trade with them in a bilateral way. This is opposed to the way in which futures are traded, as they are bought and sold in centralized exchanges. With respect to how forward price and future prices evolve, there are two different scenarios. If we assume that interest rates are deterministic, both prices should be equal, as the T forward expectation and the risk neutral expectation will lead to the same value. On the other hand, if interest rates are stochastic, then we will see that the forward price will dominate the future price if the correlation between the underlying asset and the zero coupon bond is positive, and we will see that the forward price is lower than the future price in case the correlation is negative. There are several sets of assumptions that lead to this kind of results. Finally, there is a word of notice that all the formulas that we have seen, not only in this comparison, but in the previous sections as well, depend on the assumption or rely on the assumption that the asset pays no dividends. And we are also assuming that the commodity, in case that the asset is a commodity, faces no storage costs. If any of these assumptions was not satisfied, then previous formulas should be revisited.